Hi, it's Tim, and today I'll be showing you how to use a couple more different types of blocks in Simulink. So first we're going to start off with generating an FM signal. So I'll start by making our base sine wave, so our DSP sine wave, and I'm going to set the frequency here to maybe be something like 10 Hz. So then our sample time should be 1 on 10, well, let's say 100 times that, so 1 e to the 3. We'll click OK. And what we're going to do is just go to properties and just make sure we display both of those just so we can always see. So we've got the frequency here. We'll also have the sample time. Great, apply these. Okay, and the second block we're going to use is a delay block. And this is going to simulate for us what it'd be to have a phase delay. Okay, and to change that phase value, what it's going to be, so we'll have theta, which is our desired phase, and we're going to divide that by 360, so that's the proportion. And what we're going to do is we're going to divide this whole thing so that this will be a fraction of our period of our message TM. Okay, so it's the same as multiplying it by the frequency of our message FM, and then all we want to do is multiply whatever this number is by our frequency of our sampling signal. Okay, so that's just the time of our sampling, which is going to be 1. So this would be TS. Okay, and if we want to write this out mathematically, so let's say our theta, we'll call that 90 for 90 degrees. Our FM is going to be 10, and our sample time will be 1e to the 3. So, okay, so we'll click OK. And then what else we're going to put in is a voltage controlled oscillator, VCO. So we'll notice that this actually comes from our communications toolbox. Okay, so make sure you have that installed. We'll connect that here. And essentially how this VCO works is that it's at a quiescence frequency. So that's the frequency that it's normally outputting. So we're going to set this in this case to, let's say, just say 50 Hertz. So it normally vibrates at 50 Hertz. Actually, we might want, let's go for 500 Hertz. And then we'll put our input sensitivity as, let's say, half of that. So 250 Hertz per volt. So we know that our sine wave goes from 1 volt to -1 volt. So if we have 1 volt coming into this VCO, it'll change this quiescent frequency by 250 Hertz. So it'll go to half the frequency, then hopefully double the frequency. Great, and we know our sample time is just our normal sample time. Click OK, great, and let's put up a scope and see how these 3 signals will look. Great, so I'm going to set my time. So if the frequency is 10 Hertz, 10 cycles a second, so I only need maybe 1 second for this to run. I'm going to open my scope, put it up here, and then we're going to be getting 3 signals. So first I'll just run this to just see if it works. Okay, I'm just going to zoom in. Okay, I'm going to look at my legend. Great, and I'm also going to split this up into 3. Okay, so that didn't really work, so I've just changed everything by a factor of 10. So we have a frequency of 1 here, we have delay of 1 Hertz in there, and then this is 50 and 25. Perfect, okay. So now if we zoom in on, let's just say 2 periods. So yeah, we'll zoom in on these 2. Okay, so you can see here actually, so our delay is actually causing a literal delay in our signal, and then it's going to be modulating there, and we can see that's a phase shifted. And if we look at our signal down here, we can see that there's periods of high frequency corresponding to a high in the signal and low frequency corresponding to low. Great, so for the second part, we'll be looking at how to use a select columns and reading and writing from multimedia. So first things we'll do is get a multimedia file. So from multimedia file in the DSP. Okay, and for our file name, I'm just going to browse. my desktop. I'll put in a song. Okay. So I'll just increase this a little bit, and you can see that it already loads in the sampling frequency, the bit rate, and we can actually see it's stereo. So this might cause some problems. We won't need to do this if it's a mono signal, but because it's stereo, what we're actually going to use is a multi-port selector. Okay, so essentially when we put this in, what we want to do is go into here, and all we want to do is select just either channel 1 or channel 2 of our signal. So I'll just go with channel 1 here. I'll click OK, and then we'll put this out to, we can't actually put this out to a scope. I've tried, it doesn't really work, so we'll put it out to instead our analyzer. Spectrum analyzer here. Great. And we'll run this to inf, okay, because that'll be determined by what the length of our file is. We'll open our spectrum analyzer. Great. Okay, so we're going to go into our settings, and our sample rate, again, we'll inherit this from our input, full frequency, and what we actually want to do is we want to look at our RMS voltage, and we'll view our spectrum and spectrogram. Okay, and one last thing we'll do here is we'll look at our audio device writer, which is in our DSP toolbox, and we're going to connect that to our output, so hopefully that should play over the computer. Okay, so if anything works, we should just click run. No, but of course, there's an error. Okay, so we're looking at the audio device invalid sample rate. So if I double click into this, inherit sample rate from input, yeah. We might switch this to columns and see if that works. Perfect. Don't know if you can hear me, but we'll go full screen. So here we can see a live update, but we probably just want to turn this off. Okay, and here's our spectrogram. So we can see here is a high power, and there's a low power in that frequency. This is our time as it's scrolling down, and this is our frequency. So you can see here, these are the low drum beats. This is the clarinet, and these are the hi-hats up here. Okay, I think my computer's really feeling the processing, so we might stop that there. We'll click stop up here, and that's it. That's all we should know. So today we just went through how to do some frequency modulation for your later labs, and we also looked through how to import and play and display the frequency spectrum of some unknown signals. I hope that helps, and I'll see you in the next one. Bye.